morning everyone, welcome back to In My Shed. I'm BC, finishing up the pressure test boiler for brazing and using a little bit of coated abrasives to machine out some defects. The plates are just a little bit too tight in the hole, so what I've been doing is a quick clamp to an angle plate and run around with a 120 grit flat wheel. Quite an easy job to do. This is a little homemade adapter to hold the 50 and 75mm roll-lock discs, or roll-lock style, 120 grit flat disc, and I've been using a brown Scotch-Brite disc as well. Brings them up reasonably good, gets rid of the burrs and takes the oxides off. I'll give you a quick demo of that in a minute. Now another item I've been using is this electric tool. It's just a high-speed drill, does up to about 10,000 revs. I've got a miniature tapered spindle in there and a Scotch-Brite 50mm diameter wheel. It's a loose leaf wheel, it's nailed through like a polishing mop. And I'm using that on the outside, around where the pressure fitting is going to be silver soldered in. On the inside on the same fitting, and on the inside of the ends. Very forgiving, it just conditions the surface without removing a whole lot of material, and I find that do quite a good job. Not very expensive. These you can pick up off Fleabay for about $60, but just be warned, they are not very robust. I had a flat wheel catch inside a tube, and this back housing actually detached itself and bared all the switching and wiring, and that didn't make me very happy. Okay, I'll readjust the camera, bring you in a little bit closer, and then we'll do a little bit of polishing. Okay, we're back again. Thought I'd just mention these. These are lockjaw clamps sold by Sutton Tools, and they're a quick action clamp that doesn't need adjusting. You can go to any size within its limit without having to adjust the nut, and it's tight. The only fallback with them is they won't pull up sheet gap because the clamping mechanism is very, very sensitive, and it will start to clamp even if you're not ready and where you want to be. Very good product. I've had mine for years. It just means you've got one hand free, you're not farting about. Screw knob on the back end. Now these roll-lock discs are very, very easy to change. Unscrew like that. Put a surf and conditioning disc on, and away we'll go. Make a bit of noise on this copper. Now we've got the other one plugged in. Give that a try. Prepped in just a few seconds, and I think that's ready to braze in. Now let's flop back over to the other tool. This is a variable speed grinder. I haven't got it running too fast because these mops are notoriously bad for balance. It also depends how bad the taper spindle goes into the back of them. But even at the low speed, they do a reasonable job. And for a bit of a close-up on the inside of the copper pipe, you can see that the Scotch-Brite material has brought it up quite good. And I like doing it this way because you're not actually changing the dimension or the thickness of the copper, you're just taking the oxides out. Interestingly, you can still see a few of the lines or defects in there from the drawing of the pipe, and I'm going to have to take those out. And the other end of the tube is substantially worse drawing marks. I can't understand that. But I'll finish cleaning this up, bring you back in a few seconds and show you a mock-up of the... Here's a little close-up of what the beastie will look like, except it hasn't been TIG brazed or MIG brazed yet. You can see the finish on the copper is quite bright in the areas to be brazed. And the purple disc on the right is the disc I used last just on the end of the copper tubes. And it's a medium grade. They've got some new grain in the Scotch-Brite matrix. And man, it was quick. It just took the oxides off in a sec. So now I'll mark the tubes closer to where they'll be brazed, and I'll use that same disc to clean them up right there to make sure we get a good finish. I'm not going to bother cutting that tube the length it is, after all, only a test piece. Hopefully I'll have you back here in 2 to 3 weeks time with the finished product, and then we'll be doing a progressive pressure test until ultimate failure. I'm expecting to get to between 600 and 800 psi, which is what a test boiler was taken up to, oh God, 20 years ago I think, and that was all silver soldered. If I can get up to similar pressures without the vessel failing, I'm hoping that we can have electric brazing, both TIG and MIG, brought into the code at some time in the future. These codes are like elephants, they don't move very, very fast. But we've got to have some new considerations because silver in silver solder is just so damn dear now. And I can see the copper too becoming very expensive, so if you can save material by not having to flange the plates, it'll be a winner all around. And the process isn't that difficult. You don't actually bring the copper up to a molten weld pool, you just bring it up to brazing temperature as if you were using a gas torch. So it doesn't change the metallurgy of the copper too much. Okay, I'll get this video up. Please like and subscribe, and let's hope there's some fruitful information comes out of this project. Bye for now.